Okay, geometry fans, so today we're going to talk about section 4.3, and the topic is triangle congruence postulates. Yesterday we talked about something called Cpctc, and if you remember, that stands for corresponding parts of corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay, and that's Cpctc. And what that tells us is that when you have a statement, if you know, for example, triangle WXT is congruent to triangle DAB. If you know that two triangles are congruent, then what you know is that all the corresponding parts are congruent. You know that the angles, the corresponding angles, W and D, those have to be congruent. You know that X and A have to be congruent. You know that T and B have to be congruent. And one thing, you can use the picture to match it up, but you can also use the statement. W and D are the first letters in each part of the statement. They correspond. X and A, T and B. So if the pictures are turned around or reflected or something, use the statement to match up the corresponding parts. Now for the sides, you have WX and DA, those have to be congruent. So WX is congruent to DA. You have TX is congruent to BA. And then for the last set of sides, if I look at the statement again, notice W and T, that's the first and the third letter. That corresponds to D and B, first and third letter. So WT is congruent to DB. All right, now that's true. All 6 of those things are true. Now if you think of this as an if-then statement, if the triangles are congruent, then all the corresponding parts are congruent. Think of the converse. If all the corresponding parts are congruent, then the triangles are congruent. That is also true. Now here's the problem. If we're trying to prove, if I give you 2 triangles and I say, show me that these are congruent or not, right now you'd have to show me 6 things. You'd have to know all of this to say that the triangles are congruent. That's a lot of information. Actually, you don't need 6 things. You only need 3. Okay, now I'm going to show you a couple of these and then we'll talk about them. And to do this, I'm going to demonstrate using some straws. All right, first of all, I've got 6 straws. I've got 3 sets that are the same size, basically. These are 5 centimeters, these are 8 centimeters, and then these are 6 centimeters. Okay, now here's what I'm going to do. I'm going to take 3 of them, the 5, the 6, and the 8. If I was to make a triangle out of these, okay, now how would I do this? If I take the 8 and I lay it down, and then I take the 6 and the 5 and the 6, let's see. Well, if I organize it like that, that's not a triangle, okay, because I have this missing part up here, this missing space. So I have to manipulate this a little bit. Okay, so there's my triangle. Now, if I do the same thing with these 3, do you think the triangles are going to be the same or that they're going to be different? If I use the same 3 side lengths, do you think it's going to be the same or it's going to be different? Well, if I look at this, I'll take the straw, and again, I have to manipulate this a little bit here to get this to fit. Not quite, and all right, something like that. Now look at the 2 triangles. I'm not going to measure it with a ruler or a compass, a protractor or anything, but if you look at this, I would say those look congruent to each other. Okay, they look like they're the same. So you get the same triangles if you know that the three corresponding sides are congruent. Okay, so those two sides are congruent, those two sides are congruent, these two sides are congruent. We get the same triangle every time. Now we have a name for this. Let's go back to the paper here. This is called side-side-side postulate, SSS. That stands for side, side, side. Now I'm going to read this definition. It's kind of a long definition here. It says, if there exists a correspondence between the vertices of two triangles such that three sides of one triangle are congruent to the corresponding sides of the other triangle, the two triangles are congruent. Now, what does that mean? Well, let's draw ourselves a little picture here. If you have two triangles, and let's just call these A, B, C, and D, E, F. If you have those two triangles, if you know that all three pairs of corresponding sides, if they're congruent, that's enough information to say then triangle ABC is congruent to triangle DEF. If you know that all three sets of corresponding sides are congruent, then the triangles have to be congruent. You don't need to have 6 pieces of information. You don't need to know all this. All you need are 3 pieces. Okay? Side, side, side. Side, side, side. That's one of the postulates. That's one rule that allows you to say that the triangles are congruent. All right, now there's more than one rule. You can have a different combination. You might ask, well, what about if you know something about angles? So for example, let's say I'll take the straw. This is the 8 and this is the 5. Okay, let me put those two like this. Let's see so you can see it here. Okay, so let's say what we've got here, we have a side, we have another side, and then look at the angle between them. Now again, we could try to measure this. We could use a protractor, but let's just eyeball it. What if I take another straw? Okay, again, I'll take the 8. Let me move this over here. Here's the 8. Here's the 5. What if I create the same angle between them? Okay, let me move that just a little bit. Okay, now think about this. We don't have a triangle yet because we haven't put the third side in. However, think about if you measure, if you have side, side, and then the angle between them. Okay, side, side, and then the angle between them. If those angles are congruent and these sides are congruent, what do you think is going to be true about the third side? Now I could measure this. Okay, I could take a ruler here and I could figure this out. I could measure that length and then I could measure that length. Well, guess what? That third side is going to be the same if we do it. So this is a different situation here. This is what we call SAS, side angle side. Side angle side. Side angle side. And here's what it says. If, now we're going to draw the same picture basically. So here's two triangles. Let's call them ABC, DEF. ABC, DEF. If you know you have one set of congruent sides, you have two sets of congruent sides, and you know the angle between the two sides. If we know those are congruent, and I'm going to outline this here, that's the information that we have. If you know that these are congruent, then you can say triangle ABC is congruent to triangle DEF. That has to be true. Now notice the angle is between these two sides. When I write SAS, the A is between the two S's. Okay? Now this angle has a name. It is called the included angle. Included basically means between. So angle C is included between these two sides. In this triangle, we would say angle F is included with side DF and side EF. Okay, so it's the angle between. That's SAS. Okay, now the third one that we'll look at here is called ASA. Well, A, angle, S, side, A, angle. Notice the S is between the two A's. So the picture, let's think about this here. If, let's draw our two triangles again. So ABC and DEF. Now this time we say we've got angle, one set of angles, then a side, one set of congruent sides, and then we have another set of congruent angles. If you have that picture, now again this is ASA. Look at the side, it's between the two angles. That's ASA. If that's true, that's enough information to say that the triangles have to be congruent. Okay? Now, when you looked at SAS, we talked about the angle between the sides. That's the included angle. Well, you have the same concept here, except now we call this is an included side. An included side. Okay, so BC, this side is included. It's between the two angles. And also you could say that FE is included. That's between the two angles. Okay? So side, side, side is enough information to say the triangles are congruent. Side, angle, side is enough information to say the triangles are congruent. Angle, side, angle is enough information to say the triangles are congruent. Okay, so we'll pause it there and go ahead, flip it onto the back, and then we'll look at the second section here.